Hi, everyone. Welcome to the Virtual Java User Group, an inclusive virtual community focusing on Java and surrounding technologies. In a moment, I will be handing over to our amazing host for today, Brian Vermeer, Staff Developer Advocate at Sneak. But before I do, I want to introduce myself and share some important information with you. So, hi. I'm Kim Fletcher, and I'm one of the humans behind the VJug and Devox UK. Slack is the best place to interact with our speakers and the fellow community members. So please do join us over there and join the live session channel. That's where you can drop your questions, especially if you're watching this after the live recording, and we'll try and get them answered by Matt and the rest of the community. VJug is brought to you by Devox UK, and our aim is to create a vendor-neutral space to share knowledge and best practices related to JVM and surrounding technologies. Right, well, that's enough from me. Let's bring on Brian. Hey, Brian.
Hey, how are you?
I'm doing great. How are you?
Oh, not too bad. I mean, it's great to be back here. I mean, it's been a while that I've been on VJug, and I'm so happy that you folks, like you, yourself, Mark, Sammy, just rebooted this thing, and that the Virtual Jug is back at its full glory. So thanks for that. I appreciate that a lot.
No, you're welcome, and thank you so much for coming back. But yep.
Well, in that case, we have an amazing speaker today. I mean, I've been a host a couple of times, and I tend to speak as well. But this person is someone I really like. I enjoy. I did a couple of talks with him with a few weird life hacks that we did. But I want to bring to the stage today, Mr. Matt Raible. Hey, Matt, how are you?
Hello. Good.
How's life, man?
It's awesome. Beautiful day. I'm gonna go out and bike ride after this, so can't complain.
Well, it seems a little dark at your place, but they've got the same thing here. But it's a beautiful day. Good to hear. Well, what are you going to talk today about?
So today I'm going to talk about reactive Java REST frameworks as well as unreactive, because basically what I've found is, there's a lot of these frameworks that we have, Spring Boot, Micronaut, Quarkus, but they also have a reactive flavor. And so we've been told for the last decade or so that reactive is better, or it can handle more load, or it, uses less memory and stuff like that. So I actually created a simple example, and I'm going to show you the results of whether it is better or not and answer some of those questions, or try to.
All right, great. I mean, I saw that picture coming up with you in the whole J hipster outfit, so I brought my glasses especially for that, so I would match you. But again, this is not a J hipster talk, so let's keep it to the reactive part. Anyway, I will bring up your slides right now. I think you want to hit presenter mode first, yes, and then I will have your slides right here, and I will give you the stage. But just before I mention one thing, everyone who has questions, feel free to add them here in the chat. It's fine, so I can put them on screen or in the Slack channel. There's a live sessions channel specifically if afterwards you're looking at this. If you don't look at this live, I can imagine that you still have questions. Feel free to either put it in the comments, or even better, put it in the live session Slack channel so I can point them back to Matt and he can answer them. Well, Matt, I would say take it away. The floor is yours, and I will remove myself.
All right. So welcome to Reactive Java REST Frameworks, or Java REST APIs, for the win. This photo was recently taken during the Aurora Borealis, or Northern Lights, by a guy in Colorado here, Lars Leber. So there's a link to the photo on Instagram if you want to check it out. Pretty sweet. My name is Matt Raible. I'm a hick from the sticks. I grew up in the backwoods of Montana with no electricity and no running water, and I had to walk 2 miles to the bus stop every day. So that was it was uphill both ways. That's what we like to say. I live in Denver, Colorado with my beautiful wife, Trish, and awesome kids, Abby and Jack. I also have a middle child. His name is Hefe. I bought him off eBay in 2004, and he did not look like this. It took 12 years to make him look like this, and part of the problem was Porsche engine, Porsche transmission. The wheels are just an indicator of what's under the hood, or in this case, the trunk, because it's an old Volkswagen bus. So you could call them an expensive obsession. If you have a similar obsession with classic Volkswagens, I'd love to talk to you after. So I work for, no, I don't work for anyone right now. I'm on fun employment, but I am looking for a gig. So if you know someone that needs consulting or a developer advocate, hey, I'm your guy. So today's agenda, we're going to talk about what is reactive programming, why Java. I'm going to show you how to build Java REST APIs with some of the popular frameworks. And then I'll show you how to make those into binaries with GraalVM, and then containerize those binaries with Docker. And then I'll show you some performance numbers as well as some community metrics. So way back in September 16, 2014, gosh, it's almost been 10 years now, there was a Reactive manifesto published. And it basically had a bunch of people sign it to basically say, we believe in reactive programming. And so reactive systems are, responsive, resilient, elastic, and tend to be message driven. So the system responds in a timely manner, that's the responsiveness, stays responsive in the face of failure, and then stays responsive under varying workloads, and relies on asynchronous message publishing to establish a boundary between components. So the reason I bring this up is, this was published by many friends of ours, signed by many friends of ours, and some of the people that I'll mention later on, you'll see if you want to go search for them, they are on there. I think there's 30,000 signatures or something like that. So at the time, it was very hyped. And 10 years later, now we have virtual threads. Part of my inclination was, is it actually better than traditional imperative programming? So this comparison where I'm comparing Spring Boot, Quarkus, Micronaut, and Helidon started several years ago. I think maybe 4 years ago. I was working for Okta at the time, and we published a blog post that kind of compared the top three. And then the folks from Helidon contacted me. Helidon's an Oracle project, and we're like, hey, can you include Helidon? And so it's interesting to see each of them progress over the years and get faster, get slower. Also, I've learned a ton about how to test them. Because for the most part, in the first couple of years, all I was doing is testing startup time, for instance, because my initial interest in this was not just creating, Java-based REST APIs, but also ones that were very fast to start up. Because in the Java world, I kind of felt like Python and Node were getting more favor for serverless environments. And when GraalVM came along, I was like, wow, that could really help Java. And so I kind of wanted to test, hey, how fast can these start up and how much, memory can they use? Instead of using, half a gig, can they use, just 50 megs? And so that was my initial inclination. And then I wanted to compare their reactive version. So some of the frameworks don't have reactive versions, and we'll talk about that. And then some do. And then I'll mention virtual threads as well. And so just to share my findings, and please take these with a grain of salt because I just finished creating and testing and everything yesterday. So this is very new. It's very fresh. Unfortunately, it doesn't use the latest version of Spring Boot because that was released 2 hours ago and I didn't have time to update everything. But to answer some questions, does it start faster? So this is, does the reactive version of each of these frameworks start faster than the non-reactive one? And I'll also use the word imperative for non-reactive. The answer is no, does not start faster. Might not matter in a serverless environment. And if you're running on the JVM, who cares about startup time because you're going to leave it running for a long time. So again, my concentration, my niche for this talk was serverless. Does it use less memory? No. Reactive, in my examples, in my test, does not use less memory. In fact, Webflux uses 2 times as much. Now again, that's on my machine, and I'll tell you what I'm testing with later on. Does it perform better? Yes. So Spring Webflux and Helidon SE achieved the most requests with Gatling, which is a load testing tool. I also used Apache Bench to do some load testing, and the results are different. So you kind of get to choose which load testing tool you'll believe. And then I'll also talk about Tech Empower's benchmarks a bit because they have different results as well. So I've been influenced in my career, starting 10 years ago, by these fine gentlemen, James Ward, Jonas Bonér, and Josh Long. And they were some of the first ones, that kind of told me and, influenced me to think reactive programming was better. And so I haven't used it a whole lot on client projects, but we did implement Webflux in JHipster, for example. So I have a lot of experience, doing the Spring Boot, Spring MVC flavor versus Spring Webflux. So you might be asking, why Java? Why are you trying to, prove that these start fast? Well, like I mentioned, Python and Node seem to be, eating our lunch on serverless. So, Java has had 25 years of use, abuse, and improvements. The code is available, it's open source, and it has many popular frameworks and tools. And it's hugely popular, widely used. Companies invested in Java like Netflix, eBay, IBM, Microsoft, VMware, Tesla, and Apple. So to get started with Java 21, and the reason I'm using Java 21 in this example is because it's the latest LTS. And I found that it's difficult to update these slides every 6 months when, things happen. So I'm going to stick with 21 for a while. And part of that reason too is the latest version of Gradle that these frameworks use actually doesn't work with 22. You can run it under 21 and compile, or you can run it under 22 and compile with 21 or something like that, but it doesn't work with 22. So I'm sticking with 21. You can download the Oracle JDK from jdk.java.net, or you can download the OpenJDK builds by Eclipse from Adoptium. And of course, what I recommend is to use SDKman. So you can see the curl command to install it there, and then you can do SDK install Java 21-open. You could do 22-open. You can install GraalVM. You can also install like Maven and Gradle and a lot of the SDKs we use in the Java world, and the CLIs for most of these frameworks. So what I did to make things easier, rather than showing you the code in slides and having to update those all the time, I created a GitHub repo that has all of the code samples that I'm going to show you. So you can see you can use that GH command if you want to clone it that way, or you can just go to the website and get it that way. So I'm going to stop or unmirror, mirror, one of the two. And I might forget to do it later, but I'm going to mirror this one and then should be able to show you everything, but let me make things bigger. And if you have any complaints, let me know, and I will make things even bigger. So we're going to optimize for this one. That looks a little bit bigger, even biggest. All right, so hopefully that'll work. Put that down there. And then I have this in a local repo. So if I make that in the middle, cd into dev, Java, you can see here, I can git pull origin main, make sure it's up to date. And it looks like I updated the README, so that's about it. And then I can open it up in IntelliJ. Normally, this is the time I ask if people are using, IntelliJ, you better work. Where I ask people if they're using, Eclipse or IntelliJ or NetBeans, but no one ever says NetBeans, except if James Gondelsing is in the room. So this, repository contains just a simple app that has basically a resource server, which in OAuth terms means you can pass in a JWT and access the resources. And so each one, all it does is print out the username. But at the same time, there's some intricacies going on. It's not talking to a database or anything, but the framework might be fetching the issuer, so it can do JOT or JWT validation when it receives that JWT. It might be happening when the app starts up. So that's a consideration that can happen between frameworks. Also, it has to process that JWT, grab the username out of it, and spit it out onto the screen. So there is a little bit of processing that happens there. And you can also open this up in Gitpod. So I'm going to go ahead and do that just to, we're going to use that a bit later, but it does take a bit to initialize. So I'm going to use VS Code in the browser, and I'm going to use the standard for course. Okay, and then back to IntelliJ here. The first thing I want to show you is just the imperative demos. So rather than, diving through the code and kind of trying to get confused, I wrote up these demo scripts that show you how to create everything from scratch. And so you'll see you need SDKman installed and HTTP and a free Auth0 account for the CLI. And then you can install the JDK this way. And so if I went to my terminal and I did Java version, you can see I have GraalVM Community Edition installed there. And so then you can create an auth0 access token using this command. So if I did auth0 test token, use my issuer, it'll prompt me, take me in a browser, and then say login successful. I go back and there's my access token, right? So I can grab that, put it in a local variable. Try not to get the spaces at the end. Oh, it's so hard to copy and paste when everything's so small. There we go. All right, and then we can say, export token equals, and then we have it there. And so then to make a Java REST API with Micronaut, you can do SDK install Micronaut. That's all it takes. And then mn create the app. Since you can't create one that's called Micronaut, and I have it called Micronaut over here, I had to do a move to move it. And then you create a controller here. You'll see what that looks like. It's just, mapped to hello, and it prints out the user's name. And then in the source main resources application.properties, you specify your JWKS URL. So then you can start it, pass HTTP/IE, that header to it, and you should get a 200 response. So let's go ahead and start it here. We'll do it in a different window since we need that token. Imperative, Micronaut, Gradle, run. So that started up there. And then over here, we can run it and you'll see it prints out. So that's, all it really does. And then we'll stop that one so we don't have any port conflicts. You can see to compile it to native, use Gradle native compile. And so all these examples and the Docker containers that contain the examples are all native. And so there are certain cases where you're better off running these on the JVM. But like I said, when I first started doing this comparison, I was very interested in the native version. And talking to the folks at Graal, they said that anything that's reactive based, even when it compiles to native, will take advantage of that reactive kind of architecture. And then the same thing applies to virtual threads. If you have virtual threads enabled in these apps, when you use them on GraalVM, it'll enable virtual threads as well. So that's what they told me. And if that's not right, then I'm sorry, I gave you bad information, but I believe it. So this is, how to start up your Micronaut app after you've compiled it. So I already compiled it and I can run it here. And you'll see that started up in 51 milliseconds. So my terminal. So 51 milliseconds, but I also have something in this that's a start script that I can test it. And what this does, instead of relying,
I don't see your screen anymore. Sorry to interrupt, but your screen is gone.
Okay.
So maybe you want to try to reshare your screen because I also do not see it backstage. So for some reason, it's just moved away. Let me add it again. And we see, oh, that's the inception.
All right. So you can use this command, right, to run the app like I showed, and it starts up in 51 milliseconds, but that's actually not giving you good information because what you really should be testing is how long does it take to get that first byte to make it responsive, right? So that's what this start sh script is. And if I run that for Micronaut, you'll see it says it starts up in 9 milliseconds, but it really starts up in 31 milliseconds. So that's one of the things that I've learned in the last 9 months of doing this talk is the frameworks tend to be filthy liars when they say how fast they start up. So again, Micronaut, 9 seconds, but it's really 27 seconds. If we look at Quarkus, look at that. That one, oh, what happened? That one says it started in 77 milliseconds, but it really said 128, which is usually a little bit longer. 11 milliseconds, but it's really 18, right? So it's just interesting to see that what they print out is not something you should believe. So just wanted to point that out. And then with Quarkus, SDK install Quarkus, and using small ride JWT and REST. And then that's the hello resource. And then there's some other things to make the test pass. And then you can run them, build them. With Spring Boot, you can use the Spring Boot CLI and Spring init to include web, an OAuth 2 resource server, and native to do the GraalVM stuff. And then the hello controller class actually uses the least amount of lines just because Spring's been around a while. It's got the longest package and class names, but least amount of lines of code. And then you just configure the issuer there. You can build a native app with native compile. And then Helidon has an SDK as well. You can install with SDKman, Helidon init. And for the imperative, they have a microprofile version, and that's what Quarkus uses as well. And then for the reactive, they have an SE version that uses reactive code. And so these are just, the steps to setting all that up. You do have to register the resource with Helidon, which is a little different than the others. They just automatically detect it, so that's a little different. And then these are standard microprofile properties here. So I'll have slides for these, but just so you can see, I did some tests where I basically ran that startup script 3 times and then recorded the next 5 and then averaged it out. So the fastest one to start is Quarkus. And then for the printed, Micronaut says it's the fastest. Quarkus is right behind it. But you'll notice the ones that take a little longer are actually a little more accurate when they print out what they started in versus how long it actually takes. And then there's some memory usage here, and I use this command to basically grep for the executable that each one uses and to see the megabytes used after startup. So you can see here, they're all under 100 megs to start up. After 1 request, they grow a bit, but then after 10,000 requests, they don't grow a whole lot. So, this one's pretty impressive with Helidon here, as well as Quarkus, that they're still using a minimal amount of memory even after 10,000 requests. And then virtual threads. What I've read in the documentation, Micronaut and Helidon support virtual threads by default. And so if you have Java 21 like we have, it'll use virtual threads. So that's what I know about that. Quarkus requires you to add a run on virtual thread annotation. So this would be how you modify that resource, hello resource. And then Spring Boot requires a Spring Threads virtual enabled true property. So I didn't actually enable this on either one. So all these numbers are without virtual threads. And part of the reason I did that is it just didn't seem like these are too thread intensive, right? It's not like we're using some sort of executor service or whatever. It's just returning the username. It's not doing really streaming data or anything like that. So to show the difference between the imperative and the reactive, I'm just going to diff these demo scripts because I think that's one of the easy ways to see the differences. So we're just going to soft drop both of those. And soft drop this one. And let's see if we can drag that over a bit. So on the left is the imperative and on the right is the reactive. So if we scroll down here, you can see nothing needs to be done to make Micronaut reactive. This is what I found from searching on the web, and Piotr Minkowski's documentation kind of shows, or tutorials about Micronaut. You can read those for more information, but the code didn't change at all, nor did the dependencies change. So a lot of times when I tested the reactive version of Micronaut, I was just like, well, I already tested the non-reactive one since they're the same. And it's interesting because the numbers still differed a bit. So that was like, it's the same code. Why should it differ? Right? And so everything's the same there. With Quarkus, small right JWT is for microprofile. So with Quarkus reactive, there is no microprofile. So I'd use Quarkus OIDC to do the same JWT validation. And then because of that, the hello resource changed a bit, as well as the properties. And then you can see Quarkus is getting started with reactive for more information. And then with Spring Boot, the only difference is the dependency changed. The code didn't even change at all. So that one's pretty neat that they were able to do that. And again, these are simple examples, so that's probably the reason it didn't change much. And then you can see with Helidon, it's just a different flavor, right? MP versus SE. And then this is if you want to use Gradle, because by default, it's only Maven. They don't allow you to choose between Maven or Gradle. And the dependencies are a bit different. And then the hello resource requires a fair amount more code. And the main class actually looks up the issuer when it starts. And so I did enter an issue into the Helidon project because for the others, they actually looked up the issuer, or they look up the issuer on the first request. And that was something that over the years I've complained to the projects and they've changed it. So some of them did a lookup on startup, but if you're trying to do serverless, right, it's better to do it on first request, at least in my opinion. And then the properties change a bit. And then you also have to add this enable URL protocols for Helidon SE, where you didn't for Helidon MP. And so besides that, yeah, everything's pretty much the same, and the numbers are a bit different, but I got some pretty graphs to show you that'll kind of show you the difference there. So let me make sure I got all the steps in my presentation. Did the diff, oh, the build. So the build for each one basically does a compiled to a binary, right? So you can see this is what I do before each one just to make sure it's up to date and the builds actually match between the two projects. So contents are identical there. And then workflows. If we look at the workflows here, imperative has the commands that you need to build each one into a Docker image and tag it, and then even deploy it. So that's all the build step, and then it publishes that to Docker. So all of these images are available on Docker, and there's a Quarkus, dash reactive for the reactive version. And then I also have tests here that basically run tests when Dependabot updates everything. So there's daily updates, and if you know how to simplify these, so I can use a matrix and have those as 1 instead of 4, great, but they're pretty easy to create as well. Back to the presentation, make sure I got everything. Oh, the Docker Compose file. So these are what I used in Gitpod. So you can see here there's Docker Compose that pulls in those latest images. And then for reactive, they have the reactive on the end. So if we were to go to a browser and look here, we could go to like imperative, Docker Compose, right click on it and do Compose up. And it will start all of those images. And then I ran Gatling and Apache Bench against these images where they're running on Gitpod. So the Gitpod has I think 4 gigs of RAM, a little more than you might use in a normal Docker container, but it was easy to expose the port, so that's why I did it. And you make all these public, and then over here, you can make them public as well. And so once you have all those public, then you can test them. So that's how all that worked, and I copied the URL. And so we can move on from there now. And let me just make sure I'm mirroring so I have speaker notes. This is where I probably mess up everything. Oh, it's so small. Hold on. So the frameworks versions that I used, I created all these examples probably a couple weeks ago, and then I used Dependabot to keep their dependencies up to date. So if there was a new version released, I usually get a notification, within 12 hours, maybe 24 hours of when it's released, and then those tests run so I can make sure it's in there. So Micronaut 4.4.2 uses Quarkus 3.10.2, Spring Boot 3.05. I know that 3.3.0 and 3.2.6 were, actually that's not 3.05, that's, what's it at start.spring.io? Start. 3.3.0 is the latest one, 3.2.6. All right, so let me update the slide that's inaccurate. It should be 3.2.5 here. All right. And all of these also have websites you can go to, for instance, Micronaut launch, code.quarkus.io, start.spring.io, to actually see, and create these apps if you don't want to use a CLI. And you can choose like the same dependencies I did. So as far as each one and their flavor and whether they support Reactive, Micronaut has no separate Reactive framework. Quarkus uses OIDC with Reactive because microprofiles only works with imperative. Spring Boot uses the same code with different dependencies, has Webflux versus Spring MVC, and Helidon has different dependencies in code. So that's one that's the most different between the, imperative flavor and the reactive flavor. So to build each one of these and run on the JVM, Micronaut's just Gradle build as well as Quarkus. You can see Spring Boot is boot jar as the command, and then Helidon doesn't support Gradle by default, so it just uses Maven. And then of course the double ampersands works on most Unix or Mac OS, but on Windows you'll have to split that into 2 lines. But then you could start them as regular JVM apps, and that's important if you want to run with the JVM and not as a native app, because there's some cases where it actually might work better there. And then if you wanted to put it in a Docker container, you could do it as a JVM based app as well. And so to build with GraalVM, you can install the GraalVM SDK install Java 21, or I think 22 is even an option, but I chose to stick with 21. And then you might be wondering, well, who cares about startup time? And like I said in the beginning, this is very much a personal interest of mine where, I saw Node and Python doing well in the serverless environments. And, often serverless is just someone else's computer, and you can get, better performance a lot of times if you use a JVM and keep them warm. But if you just need something in bursts, right, and you do want to use Java in that environment, then it can save you a whole lot of money. And when you're big, you don't want money like flying out the window, right? So, it's important to use GraalVM in a serverless environment, I think, if you want to compete with Python and Node. And then there's various use cases for native images. So this is from Dan Vega, and I think it's a great, diagram that shows the JVM is likely better for high throughput, high traffic, huge memory and CPU requirements versus like native images recommended for low memory. Maybe you only have 100 megs to use. Maybe you're on a device or an IoT or something like that. And CPU, or the functions as a service, right, are scaling it back to 0. So if you need the high throughput, just stick with the JVM. And so to build with GraalVM, each one has unique commands. Quarkus is the longest. They're all difficult to remember, but it's nice that Micronaut and Spring Boot at least use the same one. And then next, I will show you how to take each one of these and put them in a Docker image. So then you can publish, use it in a Kubernetes environment, or just use them for tests like I am here. So with Micronaut, you run a Gradle command and then Docker tag. And with Quarkus, you run a Gradle command and then a Docker build with a Docker file and then tag it as well. And if I mess these up for any reason, please let me know and I'll get those fixed. But I'm pretty sure they work because I run them in GitHub Actions. With Spring Boot, it's Gradle boot build image. And then with Docker, you tag it. And then with Helidon, it's all Docker. You don't actually use, Maven for it. It has the Maven commands that run from that Docker file. And so now we'll get into performance, startup performance of each binary, as well as their Docker version. And then what I did is I realized that, I'm on a Apple M3 and it's fast, right? CPU is awesome. And that's not what you run in production. So I used an EC2 instance that uses T2 micro, which is like 1 CPU, 1 gig, to kind of test out how fast it starts with Docker, which I think is more of a real world situation, right? That's might be where you deploy to production because you really want it to be, as small as possible as far as, the VM's concerned. Otherwise, why are you using GraalVM? And then we'll get into native memory usage, right? This is how much, when I started on my M3, how much memory it's using. Docker memory usage, so this is, again, on EC2. And then the load testing with Apache Bench and Gatling, I used my local client, my M3, to talk to Gitpod. And so I could have certainly used like EC2, that instance there, to hit the Gitpod instance, but I just figured, the variance between frameworks is going to be shown regardless of where the client comes from. So to start with, imperative native startup, right? This is Micronaut, Quarkus with MicroProfile, Spring Boot with Spring MVC, and Helidon with MP. So there's two things here. One is the printed version, right? And I need to update my slide here to say printed. And then the second one is the scripted version. So this is the printed duration. So if you believe what the frameworks say, Micronaut starts the fastest. But if you use the scripted version that starts it and then hits localhost 8080 and sees when the first one responds, Quarkus starts the fastest. So again, quite the difference here, right? I like to say the frameworks are filthy liars. Like if they're going to print that startup time, at least make it more accurate. But you can see there's a wide variance. I think, Spring Boot and Helidon are a little more accurate, but they're still like 10 milliseconds off. So again, these tests are run on a 2023 MacBook Pro M3. And then to test the Docker startup time, right? I published these on Docker Hub. You could use them as well and run these tests as well. There's a start-docker.sh script, which I borrowed from Micronaut, and allows you to test jars and Docker containers and everything. And so this is on a T2 micro, and I basically ran it 3 times and then 5 more and then averaged it. So you can see 34 milliseconds for Quarkus, Micronaut's second fastest with 50 milliseconds. So again, that's pretty fast, right? And then for the reactive versions, they're a little longer, right? So you see there, Quarkus is still the fastest. Imperative, reactive, imperative, reactive. But it's a little longer to start up. So then imperative native memory usage, this is after 10,000 requests. This is locally. So I'm running a memory.sh script, which is in the project, and you pass in an access token, and then you pass in the framework. So it's memory.sh token space Micronaut or Quarkus or Spring Boot or whatnot. So you can see here the least amount of memory used is by Helidon. So this is Helidon microprofile, their 4.0 version. Helidon 3 and 4, there's a lot of performance differences. They're based on Netty. They use virtual threads, so they do win that one, but narrowly, right? Like Quarkus is right there with them. Reactive memory usage with Webflux, it's quite a bit more. All right, you can see the difference there. But with Quarkus, it's quite a bit less, right? 71 to 56. So Helidon's pretty similar between the two. And then Docker memory usage. So this is on the EC2 instance. I started up a Docker container, and then I ran a memory-docker.sh script that just hits it and sees how much the memory used after 10,000 requests. And so you can see, I think this is actually only 10 requests. 10,000 seems like a lot, but I'd have to check that script. And I'll update the slides if it's only 10. But you can see Docker memory usage, Quarkus wins that one with imperative. And then with reactive, it wins as well. So, but Helidon reactive is quite a bit less memory used versus, Spring Boot is a little more with reactive. So then I also used Apache Bench to load test everything. And on my Mac, I had to run ulimit-n 10,000 first. And then basically I started with 1,000 concurrent users, and I ramped up to 5,000 requests per, and I set the timeout to 120. So this is hitting Gitpod standard instance where it has 4 cores and 8 gigabits of RAM. So it's a lot different than the T2 micro instance you'll get with EC2. And so that script is in the test directory under ab.sh. So the imperative Apache Bench results, you see this is requests per second. Helidon gets the most by a wide margin. It can process almost 375 requests per second versus something like Micronaut is 66 requests per second. And then the time per request, you can see that Helidon is the lowest. And then the time for all the tests to execute, right, and have all these 5,000 requests go is the lowest with Helidon at only 13.6 seconds. And then the reactive versions, I made sure that you can see the scales are the same. The request per second, Quarkus gets more, right? But it's 125 versus almost 200. So reactive does perform better there. Time per request is much lower with Quarkus. And then the time for tests is lower as well. So that's Apache Bench. And the weird thing is I do find different results between Apache Bench and between Gatling. And with Apache Bench, there was a fair amount of, timeouts, or it didn't complete all of them. And so I did have to adjust like the number of concurrent requests versus the total number of requests and to get them all to work. So I did spend more time like tweaking it, but also the results were different, especially because look, Micronaut, right? That green line changes and those are the same apps, right? So it's like, it shouldn't change at all. They're the same apps. So then I am familiar with Gatling. I've used it quite a bit in the past, and I think it's a great load testing tool. So if you go to the docs, you can see the prerequisites. You need Java up to 21, and then supported languages. You could use Java, Kotlin, or Scala. And older versions only supported Scala. And then you can write a simulation, which basically hits an endpoint and verifies that a 200 happens. And so in this code here, it basically ramps the users up to 10 over a 2-minute period. And, scales accordingly. It goes up to like, 10,000 requests basically. So to configure it and run it, you have to tell it the URL. This is from Gitpod that you can copy and paste from that ports window. And then you export the token, and then you run Maven Gatling test after you've downloaded it. So that's where you get the download from at the link there. And then you can go ahead and run it after you copy the test that I wrote in the project. And then it'll basically execute in 2 or 3 minutes and tell you how everything succeeded. So the first results I got were for Micronaut. You can see here, with the imperative version, 10,000 requests, passed all the 90 tests, and you can see there were some errors there, about maybe 20% or so. And then it shows the number of responses and how at some point maybe it was garbage collection or something like that, but these are native, right? So there shouldn't be garbage collection, but all of a sudden the number of responses goes up there about halfway through it and then tapers down at the end. So that's the number of responses per second. And then the imperative Gatling results, basically all of them, you can see I put a logo on each one of these. So this is Micronaut, gets about up to 300 or so, right? 350 maybe, responses per second. And then we have Quarkus, and then we have Spring Boot, and then we have Helidon. So if you look at this one and you just look at that number of responses graph on the top, you'll notice 300, 200, 400, 160. So Spring Boot delivers the most number of responses, in this case, using Spring MVC. And then if we compare that to the reactive version, this is the number of requests that went through with Micronaut versus Quarkus. One's around 10,000, one's under 10,000. And then Spring Boot is over 10,000, or Spring WebFlux. And then Helidon SE is above 10,000 as well. So for that one, you can see those pie charts. The yellow part kind of shows you the error rate. And it seems like Helidon and Spring WebFlux are kind of in a tie there, right? I mean, there's very slight difference between them on the errors thing. And then for the full Gatling results, just to show them, with Micronaut, Reactive performs better, which is interesting because they're the same app, right? So it shows you there might be some differences in the environment or the internet connection, right? There's no difference in the images, really. No dependency difference, no code difference. They are running, on Gitpod, and I am coming from my local machine, so maybe that's it. But, the one on the left is the imperative. The one on the right is the reactive. And you can see there's a difference in the number of requests. Quarkus, imperative gets more number of requests. Spring Boot, reactive, gets more requests. So that one is better than Spring MVC. And then Helidon SE also gets more requests than Helidon MP. So in the Gatling case, Spring WebFlux and Helidon SE kind of win that battle. And then there's also the tech empowered benchmarks, right? And so what I did here is, it's kind of funky. If you go to the UI, it's got this way of filtering everything. And so you have to deselect everything and then select the ones you want to filter by. So I deselected all the frameworks and then I just chose these 4. So in this instance, it says Helidon 4 is the fastest, Quarkus is next, and then regular Helidon. And then you got some Quarkus and some Micronaut, and Spring's way down at the bottom. Well, it's interesting because just yesterday, the Quarkus Insights crew had a whole discussion on Tech Empower and these benchmarks. And so Francesco Negro was the guy that was mentioning and discussing all these results. And if I butchered your name, I'm sorry for pronouncing it wrong. But what he discussed and what he talked about is that some frameworks don't even request or process or request headers or body, so, or do content negotiation or anything like that. And Quarkus does. So he was basically responding to how Helidon 4 was really, the flat out winner. And the version of Quarkus that was in there was very much like a full, what you as a developer would want with an ORM and everything like that. So they've started to do some optimizations. It still uses Java 17. There's no virtual threads. And it's just kind of interesting. And then Helidon 4 uses Vertex, which is part of Quarkus, related to Quarkus, adjacent to Quarkus, as its database client. So if you want to know why maybe you shouldn't rely on those Tech Empower results or benchmarks, check that out. And I was actually on Quarkus Insights back in August of 2023, and we talked about me comparing these Java REST API frameworks, not the reactive versions, just the imperative versions. And they gave me a lot of advice about actually not believing that startup time and doing that scripted startup and doing the Docker testing and doing it on T2 Micro. So thanks to Max and Holly for, encouraging me to do that and, making these performance testing metrics better. They also recommend Hyperfile, which I haven't looked at, but it's basically a recommended way of testing these micro, services in a distributed benchmark framework. And so now I want to go into community metrics and comparing them. I know we only have 14 minutes left or so, so this should be pretty quick. But one of the things that you should know is first of all, these are just pretty graphs and they might not mean anything. So take them with a grain of salt. But also, it's important to remember that Micronaut 1.0 was 2018, October 2018, versus Spring Boot 1.0, they did it April Fool's Day 2014. So that's, 4 years difference. So Spring Boot had quite the head start. Quarkus was November 2019, so almost a little more than a year after Micronaut. And then Helidon was February 2019, so, before Quarkus even. So the late bloomers basically had an easier way to make native work because they did it by default, and Spring Boot kind of had to catch up on the native front. So just from a community standpoint, Stack Overflow tags, most people have problems with Spring Boot, right? No. It's basically one of those things that I consider like a mailing list, right? If it's very popular, has a large ecosystem, a lot of people using it. So I do think this is accurate at the size of the community. GitHub stars, Spring Boot is the most popular. Micronaut has 6,000. Hasn't really grown much versus Quarkus is growing. And Helidon, I think it doubled like in the last year. Maybe a bunch of Oracle employees went and started. Not sure. But the GitHub star growth, you can see that Spring Boot is still growing the most. So even though the others have been out and kind of eating into Spring Boot's market share, it's still growing at a higher trajectory. Jobs on LinkedIn. So me as a fun employed person and unemployed, and I am looking for a job, I'm just not goofing off. I use LinkedIn the most. So in most of these comparisons in the past, I used Indeed, but I've never been looking for a job in a while, right? So it's interesting to have this perspective now because I don't search for these frameworks, right? I search for senior software engineer, or I search for senior developer advocate. I don't actually search for a framework and then choose a company or a job based on that. So maybe this is kind of hokey, right? But I think it's an accurate reflection of what companies are hiring for, maybe. But the interesting thing is, look at this. So LinkedIn, in my opinion, seems better than Indeed, just in my experience over the last couple months. But Micronaut has 1 job, Quarkus has 0, Spring Boot has 665, and Helidon has 1628. Like, what the? Like, even with Helidon, I searched the job listings and it's not mentioned in there. So there's some weird thing going on LinkedIn where you search for Helidon and there's a bunch of jobs, but there isn't really. So I turned back to Indeed. And what I found is there's 10 Micronaut, 26 Quarkus, Spring Boot has a bunch, and then Helidon, again, not so much. But the interesting thing is searching for microprofile, you might think that's a skill, 0 on Indeed. Jakarta EE, 19. So we can see that these frameworks have kind of taken over from what used to be popular as, Java EE. Java itself has 21,000, JavaScript 15,000. We're beating them there. Kotlin only has 636, and AI has 25,000. So more than anything. So is AI really coming to take our jobs, or are there more jobs in AI than anything? Who knows? So Twitter followers, Spring Boot has the most. Others got quite a few. You as an individual be happy to have this many Twitter followers as, Helidon does. And then what I invite you to do is run your own tests, right? Don't just believe what I found because obviously I'm on a nice laptop, but maybe you're running on, Linux or Windows, or you're deploying somewhere else, right? You should clone this repo or fork it, send pull requests if you find a way to enhance it, and, try it out yourself. See if you get similar benchmarks. And then the unanswered question that I didn't really dig into much was R2DBC, which is for reactive databases with like Spring Boot, or Hibernate Reactive. Don't know. If you have any insights into that, would love to hear it. And thank you for attending. You can keep in touch with me on my website at raibledesigns.com. I'm on Twitter and GitHub at mraible, and then LinkedIn in mraible. My presentations, including this one, are up on Speaker Deck. Obviously, I fixed a few typos, so I'll be updating that, but it's there right now. And then most of my code these days is at mraible on GitHub. Thank you.
All right, man. That was great. Thank you. First of all, that means that you have more Twitter followers than Helidon, and I think also than Quarkus, which is great. No,
right?
You're doing a great job. Now, one question I have: what is, if you have to pick one of these 4 frameworks that you're doing, and you need to, like, you have carte blanche, you have that greenfield application. Which one would you pick? What is your go-to?
So mine's Spring Boot because I have the most experience with it, right? But that's because they got like a 4-year head start on everyone else, right? So I didn't even start using the others till 4 years later. I've had the least amount of struggle with like Micronaut while doing all these, but also at some point the Micronaut committers came in and said we can optimize Micronaut, make it faster. And at one point it was, the optimized version was faster, and now it's not anymore. So that's weird, right? And then and with Helidon, that one's been probably the most headache, right? It's had the most problems, but I've entered issues for it and they fixed it. And now you've seen with the results today, they're actually performing, very well and even beating some of the major ones.
Also, a question, like, because you compare the, well, as you called it, imperative versus reactive thing, like, and this is also based on one of the questions. Can you tell me whether virtual threads are going to be the de facto standard in Java over reactive programming, considering the learning curves, debugging, and support aspects? What is your thoughts around that?
Yeah, I did have a quote from James Ward because he did a modern Java talk a couple years ago, maybe just a year ago, and he documents it on InfoQ, and he mentions that very thing. He's like, I think virtual threads and Loom is going to make a lot of developers be like, I don't really need to learn reactive programming now, right? This kind of solves the problem for me. And I think it certainly does to an extent, but I think one of the things you have to remember is like reactive programming is about non-blocking IO. And if you do something and use a JDBC driver that's blocking with virtual threads, you're still going to be in a blocking environment. So you still might have to use those non-blocking JDBC drivers or whatnot to get that high performance. And I expected a bigger variance, right, between these than I saw. So maybe my Gatling tests need to go up to 100,000 users or whatever and make the whole thing fall over and see where that comes. Because, what I heard from the Spring folks is you really don't need Spring WebFlex until you have over 5,000 requests per second. And I don't know if I really reached that, right? So I think there's more testing to be done. This is a first iteration, so hopefully it'll improve over time.
Interesting. I mean, the hardest part, what I find about reactive programming is whenever you need to debug stuff, because it's the mind model you need to keep there is like, okay, we were always used to synchronous communication and to synchronously debug things, but for me that is like the thing, like that's the most hurtful in the whole reactive mindset. So if you would again create an application, would you start from reactive like from the get-go, or would you go the virtual threads way and maybe do something different if you need to?
I think I would go imperative first just because it's more familiar and it's easier to know. The beauty of reactive is it's kind of like you learn the Java Streams API, I feel like, and I think that's good knowledge to have, right, in that functional style. But I kind of compare it to monoliths versus microservices, right? You shouldn't start with microservices. You should start with a monolith and then migrate to microservices. I kind of feel very similar with these frameworks that you can probably start with Spring MVC or Micronaut or whatever and migrate to the other one or migrate to the reactive version. You saw in a couple of them, there is no migration, right? It just, it just supposed to work, right? And then Helidon is probably the biggest one that you should maybe make a choice at the beginning because the code's going to be totally different, at the end between them.
There was a question here about how virtual tracks work on non-reactive Java and on reactive Java. I'm not sure if I totally understand the question, but maybe you can shine a light on how virtual threads work.
And this is a question I had for the GraalVM folks because I basically expected, like, if you're using GraalVM to compile a virtual threads app or a reactive app, like, do you still get those? They seem like JVM-based behaviors, right? And they told me that you still get those same behaviors even when it's a native binary, which I was like, wow, that's really cool. But in this case, to answer this question, I think they would work the same.
I guess so. The question is if you need to use virtual threads if you are in a reactive environment. If that is, I'm not sure.
But you'll notice, like in my demo script, right, I never said anything about virtual threads and reactive because my guess is that you wouldn't, right? You wouldn't try to use virtual threads because you're using reactive to work around that.
Yeah, I guess so. All right. let me see what we have. A couple of more questions. Oh, maybe this is a question about Micronaut, and I'm not sure if this fits the scope, but maybe does Micronaut use Jackson or JSON processing, or does it use its own library? I have never used Micronaut before, so I don't know. So, but you've at least tried it, so
I'm gonna guess it uses Jackson because they use a lot of the same things that Spring Boot does. But I could be wrong. I'd have to run a dependencies tree and see it on those projects to see what it pulls in.
All right, makes sense.
And I'm sure you can switch it, right? Just like Spring Boot, you don't have to use Jackson. You can use something else, JSON or whatnot.
Probably. Well, I think that are pretty much all the questions. There was one question that was outside the scope, but I will bring it up though. That somebody has been struggling about things around Spring authentication. Luckily, somebody already jumped in saying like, "Hey, look at the examples that Josh Long, Dan Vega, and Laurencio Spilka have. They have a lot of material around Spring authorization, and that might be very, very useful for that. But I think it's a little bit out of the scope of this presentation format. So I'm glad that Simon already answered that one. But that's for now, like the questions that were in the chat, and people are very happy. Like there are thank yous and a lot of like much appreciated, great session. So thank you for this one, Matt. I need to look into this much more, and at least into the other frameworks as well, because I'm more or less a Spring Boot person as well. So.
Right, and I think this needs to be done on a larger application because these are all pretty simple, right? They're just processing a JWT. So one of the things that I had initially hoped to get into, but I didn't, was JHipster does have support for all these frameworks, and it has the ability to get them into GraalVM images, right, on a Docker container. So it'd be interesting to see when that's more of a, not a whole built application, but it's a little more robust and it does talk to a database and stuff like that. Like, what are the performance numbers when you're load testing something like that? So maybe I'll get to that later this year.
If you ever find out why the difference between the Gatling and the Apache stuff, what the difference, I would love to invite you back and talk about that, because that was weird. That was honestly weird.
Totally.
All right. Folks, if you have more questions, feel free to jump over to Slack and put it in the live session channel. I know that Matt is there as well. I am there. Oh, Kim is there as well. Like, we are all there. If you have more questions, feel free to put it there, and we can answer that asynchronously. But Kim, I leave the rest up to you.
No, well, thank you both so much. It was such an interesting session, and yeah, hope to have you both back real soon. So yeah, thank you very much. And thank you everyone for joining. So let you know, our next session is going to be on the 27th of June, and that'll be with the amazing Lisa Reyes, who will be speaking about Java meets AI and how to build LLM-powered applications with LangChain 4j. So hope to see you there. Take care. Bye for now.
Bye-bye.
Bye.